Welcome back. In this lesson, we're diving into NAT gateways, an essential component for managing secure outbound internet access in AWS. Before we talk about NAT gateways, let's first understand the concept of NAT, that is Network Address Translation itself. Don't worry if that sounds a bit technical. I'll break it down in a way that makes complete sense. What is NAT? A network address translation. Imagine your home has multiple devices, phones, laptops, tablets, all connected to the internet. Each device has its own private IP address, but when they access a website, the request appears to come from one single public IP address assigned by your internet provider. That's because your router at home acts as a NAT device. It translates the private IP addresses of your devices into a single public IP before sending traffic to the internet. Then, when the response comes back, the router knows which device made the original request and forwards the response accordingly. This allows multiple devices to share a single public IP while keeping their private addresses hidden from the outside world. Now let's bring this analogy into AWS. What is a NAT gateway in AWS? In AWS networking, your VPC, that is Virtual Private Cloud, is like your house, and your subnets are different rooms within it. Some subnets are public and connected to the internet, while others are private and isolated for security reasons. But what if instances inside a private subnet need internet access? For example, to download software updates, pull code from GitHub, or connect to an external API. We can't use an internet gateway because that would make them publicly accessible, exposing them to security risks. Instead, we use a NAT gateway. A NAT gateway acts as a middleman, allowing instances in a private subnet to initiate outbound connections to the internet without allowing inbound connections from the internet. How a NAT gateway works. Here's how a NAT gateway enables secure outbound communication for private instances. 1. A private instance inside a private subnet wants to access the internet. 2. The request is sent to the NAT gateway, which resides in a public subnet. 3. The NAT gateway translates the private IP to a public IP and forwards the request to the internet. 4. When the response comes back, the NAT gateway translates the public IP back to the private IP and delivers it to the correct instance. This ensures that outbound internet access is available while keeping private resources hidden from direct exposure. NAT gateway versus NAT instance. Before AWS introduced NAT gateways, users relied on NAT instances, which are simply EC2 instances configured to perform NAT functions. However, NAT instances required manual setup, maintenance, and scaling, making them less reliable and more effort-intensive compared to NAT gateways. Let's look at the key differences. High availability. NAT gateways are managed by AWS, ensuring automatic failover and reliability. NAT instances require manual failover configuration. Scalability. NAT gateways automatically scale with traffic demands, while NAT instances require manual scaling if traffic increases. Security. NAT gateways only allow outbound traffic, blocking inbound connections automatically. With NAT instances, security settings need to be configured manually. Maintenance-free. AWS fully manages NAT gateways, so there's no need to worry about updates or patches, unlike NAT instances. Because of these advantages, NAT gateways are the recommended solution in modern AWS environments. Key features of a NAT gateway. Now let's break down the most important features of a NAT gateway. High availability. NAT gateways are highly available within a single availability zone, AZ. For even higher resilience, you should create one NAT gateway per AZ. Automatic scaling. They scale automatically to handle up to 10 Gbps of bandwidth, eliminating performance bottlenecks. Outbound-only traffic. NAT gateways allow instances in private subnets to initiate connections out to the internet, but prevent any inbound traffic. Elastic IP requirement. Each NAT gateway requires an elastic IP address. This is a static public IP that AWS assigns to your account, fully managed by AWS. AWS takes care of all the maintenance, patching, and monitoring, so you don't have to. When should you use a NAT gateway? You'll typically use a NAT gateway in the following scenarios. Private subnets with internet access. If instances in a private subnet need to download updates or access external services, a NAT gateway enables this securely. Secure outbound traffic. You want to allow outbound internet connections without exposing private instances to inbound threats. Multi-tier architectures. In a multi-tier setup, web servers might live in a public subnet, while application servers and databases are in private subnets. A NAT gateway allows application servers to access the internet securely, while databases remain completely isolated. Understanding NAT gateway costs. While NAT gateways are extremely useful, they are not free. Let's go over the costs involved. Hourly usage. You're charged for every hour the NAT gateway is active. Data processing. AWS charges per gigabytes of data that flows through the NAT gateway, both inbound and outbound. Elastic IP cost. Since each NAT gateway requires an elastic IP, any additional EIP charges may apply. Standard AWS data transfer fees. If your instances send or receive data over the internet, regular AWS data transfer costs apply. For example, if a NAT gateway is running 24/7 and processing 100 GB of data per month, you will be charged for hourly usage, data transfer, and elastic IP allocation. Best practices for using NAT gateways. To make the most of NAT gateways, here are some best practices to follow. Deploy one NAT gateway per availability zone. This ensures high availability and prevents a single point of failure. Monitor usage with AWS CloudWatch. Keep track of traffic and performance metrics to optimize costs and efficiency. Use security groups and NACLs. Define strict outbound rules to restrict unnecessary internet access. Consider NAT instances for cost optimization. If you have a low traffic workload, a NAT instance might be more cost effective, but remember, it requires manual maintenance. Recap and what's next. Let's summarize what we covered. NAT gateways enable outbound internet access for private instances without exposing them to inbound connections. They are fully managed, highly available, and scalable, making them easier to use than NAT instances. They are best for private subnets that need secure access to software updates, APIs, and external services. Cost supply based on hourly usage, data transfer, and elastic IP allocation. In the next lesson, we'll move forward with a hands-on demo where we'll create a NAT gateway in AWS and configure it to allow private subnets to access the internet securely. Thanks for following along, and I'll see you in the next video.